ALS 102, Topographic Wetness Index from LiDAR terrain models, helps forest roads maintenance. One of the main uses of a LiDAR survey is to obtain high-resolution digital terrain model. These models are essential in geomorphological and hydrological studies, which assist in making decisions about planning, operation, and sustainable forest management. Since water is the main erosive agent, it is essential to study the impacts caused by it to help the adoption of soil conservation practice. In this context, the Topographic Wetness Index allows the study of the effect of the terrain on water behavior. One of the components of forest production most affected by water is roads, as they have a surface that favors surface runoff. Mountainous reliefs are aggravating in this situation because of the water velocity and proportional to the slope of the terrain, which causes greater recurrence of maintenance. Therefore, the objective of this work was to test the use of the Topographic Wetness Index in the identification of areas suitable for the accumulation of water in forest roads in order to optimize the maintenance of the survey in them. In the study area, the Topographic Wetness Index values range from 0.59 to 21.97, and the critical points evaluated presented values higher than 9, which was the limit for determining the critical regions. With this, it was verified that only 7% of the areas of the roads presented values higher than the defined limit. In addition, all the regions indicated in field for maintenance were foreseen by the model. It is concluded that the Topographic Wetness Index model is a good support tool in the operation of forest roads, directing the surveys to the points that are likely to require maintenance, significantly reducing the area of survey in the field, streamlining the process and optimizing resources.